Okay, well, let's get started. I want to look at this lab 14. Like I said, you can kind of look through it with me if you want, if you have your own, and write it right on there, or just write some of these things in your notes. So this is going to be, kind of helping you with reviewing to get ready for this final. Okay, so and I did get the tests corrected. Sorry, I keep thinking of things that I want to tell you guys. I did get those exam 3s corrected, and overall there were pretty good scores. You can go in there. Make sure that you go and look at the feedback that I gave you, though. I write right on the test to give you the feedback, and I showed you with the card comparison project how to look up that feedback from me. Right? And if you're not quite sure how to do that, look back in one of those announcements. I gave you step-by-step instructions of how to look for that feedback from me, okay? But make sure that you see it because, remember that if I would use the test as something to kind of guide you as far as what might show up on the final exam too. So look at exam 1, exam 2, and exam 3 and make sure, that you go through mostly the things that you missed, but you definitely want to make sure you review over the things that you didn't miss too, make sure it's still in your head and in there good. Okay, but I would like to say that I really feel like there was some cheating that went on in the test, and of course I can't prove it and stuff, and I'm not going to pursue it because you guys know if you're being honest or not on it. But, I just want to warn you again that you are just doing yourself a disservice if you're not learning the stuff, because if you think 1010 is hard, 1050 is a lot harder. And if you don't have this stuff down, 1050 is going to be an uphill battle for you. So please, 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 don't be using other people or other things. Like some of the ways that you guys were writing things out looks like, if you typed it into an app, one of those apps that figures things out for you. And, I can tell by the way that it's written and stuff, whether it's your work or not. So, so just know that, you're not doing yourself any favors by doing that. But those of you that were honest on the test, I really appreciate it. And I could, tell that the majority of you were honest. But please, on the final exam, okay, just be honest with yourself. Get the things studied that you need to study. We're doing a great review, trying to help you know what you need to study, right? So please be honest in that, okay? All right, so let's look at some of these things together, because I want to make sure that you're feeling good about what we need to go over for the final here. So remember on the test, right, you're going to see a lot of different tables and stuff like that. You've seen these on tests in the past where it's asking you what kind of function it is. So we've talked about, is something, linear, quadratic, is it exponential? And we said, we could tell, by some patterns that we see here, what it might be. So on this first one, it might be kind of hard to tell on the first, 2 here that you're looking at, all right, to go from here to here, what's happening. But maybe as you get down here further, it might be easier to see, right? How am I going from 3 to 15? Well, I'd be timesing by 5. How would I go from 15 to 75? I'd be timesing by 5. And so that's what's happening on all of these, right? So when I'm multiplying by the same number every time, right, repeated multiplication like this is exponential. So this would be exponential. And we can tell because it has this, common ratio is what we called it before. Right? It's multiplying or dividing by the same number each time. Okay? And then if I was trying to write this, I'm not going to do exactly what this says here, but if I wanted to try and write this as an equation, right, we don't know what the y-intercept is here. It doesn't give me when x is 0 what f of x is. But we talked about that before, how we could figure that out. Well, if we're timesing by 5, right, then you're kind of like you're dividing by 5 to figure out what that is going to be there, right? So like if you did, like if you did 0.6 divided by 0.12, right, you get 5, right? And so you can kind of see that that's what's happening there. And so if I do 0.12 divided by 5, right, that's going to give me this point, I'll put it in up here, the 0.024. Right, so it's kind of a small number here, right? But this is if I'm going backwards here, right? Trying to find it, right? And then if I try and write this, right, in that form, remember our exponential form is y equals a times b to the x power. And a was our start amount, right? And then b is the amount that we are, moving by here, right? So is going to be our common ratio. So our start amount, right, is going to be that 0.024 and then times our 5, right, because that's the common ratio here, times 5 to the x power. Right, so we kind of talked about how to write those things in. Remember that A is our start amount and B is that common ratio, what's being multiplied over and over again. Okay. Let's see, we're going to skip part B. Let's look at part C though. Right, so on part C, we've got, catering company charges $110 plus $10 or $15 per person to cater a dinner. The function C of x models the cost of hosting the dinner for x people. Right, so if we're looking at this, right, so now it's giving it to us in words, not as in table form, but it's telling us that we have this start amount, right, this $110 that you're going to be charged no matter what, right, just like a setup fee or something like that. And then on top of that, you're going to be charged $15 per person, right? So x is the people, the number of people, and C of x is the model there, or is going to be the total cost. So we'd have the cost equals, right? And then so 15 would be my slope on this. This is going to be my constant rate of change because it's going up by $15 every time. And then this 110 is going to be my start amount, right? Because I am going to be charged $110 no matter what. All right, so I'd have 15 times x times however many people there's going to be, plus that 110. Right? And then depending on how many people there are, like if 50 people are going to be, at that dinner, then we put 50 in place of x to figure out what that total cost would be, and so on. So we could figure out the cost for any number of people on that. But so what type of function would this be considered?
Be linear?
Yeah, it'd be linear. Okay. So this is linear, and you can tell it's linear because of that, the constant rate here, right? It's, increasing by $15 for every person, right? So you're adding 15 every time. All right. So this one also, so this time they're giving us an equation and asking us what kind of function it is. Well, it's also linear, right? We can see that we're, you know, this is our slope and this is our start amount, right? Our M and our B. So this is linear, so you can see it in, you know, if it's given to you in as equation, right? But then I said over here, the slope is 14 and, right, it's always going to be the number in front of our x. And remember, that slope we also call that constant rate of change, right? So you'll hear it that way also. And then the y-intercept, we always want to write our intercepts in, you know, this form of like in an ordered pair. So when 0 is x, that means y would be negative 18.2. Right? That is our y-intercept. Okay. All right, so this is just, you know, we're just kind of going through different types of things here. So I want to have you look at part E now, and I want to see, you don't need to complete the table anymore, just see if you can find the pattern that's happening there as you're moving down the table. Okay, let me give you just a couple minutes. What is happening here? Been able to All right, so did you guys figure out what is happening here? You tell what kind of an equation it is. What's happening from 62 to 40? Well, we're subtracting 22, right, to get there. Right? If you do 62 minus 22, you get 40, right? But then if we try and do subtraction again, right, it's not going to be 22. Now we'd be subtracting 18. 40 minus 18 gives us 22, right? And then, you know, what's happening here from 22 to 8? Right, so we're minusing 14 there, right, and then minusing 10. So maybe at first glance you're thinking, this isn't one of those ones that we've talked about, right, because it doesn't look like there's any kind of a pattern there. But remember that you need to also check for the second difference as well. So if you're adding or subtracting, right, and they don't look like it's the same there, and you're looking at it going, well, I'm not multiplying by anything to get to those next numbers, right? So if I'm looking here, well, what am I doing? So negative 22, right, plus 4 would give me negative 18. Negative 18 plus 4 would give me negative 14, and plus 4 again. All right, so I can see that I have a common second difference on this. Right, the common second difference of adding 4. All right, so when we have that, what kind of function does that mean that we have? Yep, and some of you are saying that's quadratic. Right, so that is going to be our type here. Okay, and some of you missed this on the last test. You weren't seeing that pattern, so just make sure on the final exam, right, to look for this. If you don't see something in that first difference, right, look in the second to see if there's something there that's happening. Okay, so that would be quadratic. All right, and then we didn't talk about these type. Remember I said we were going to skip over some of these, and they're not going to be on the final exam or anything, so you don't have to worry about that. Okay, you'll talk about them in 1050 when you get there. We just kind of ran out of time to do them, but it's all right because you'll get to them next semester or whenever you take 1050. All right, so what about this one? What type of function is this? Anybody have a guess of what this type might be? And why you think it's that? Okay, I guess I'm not sure if you guys were saying this before when I asked, but you know, it's quadratic again on this, but how can we tell it's quadratic? Well, remember, if you multiplied this all out, like if you FOILed it all together, right? Think about even if we just do these first two right here, that's going to give you 42x squared, right? And that's going to be your highest exponent on there, right? It's just in factored form. It's just a quadratic in factored form. And sometimes it's nice to have it in factored form because remember, we can easily find the X-intercepts, right, from that. So on the first question on your test, there was something kind of like this. And so those of you that missed it, right, some of you are just getting confused, I guess, whether, you know, how to find the X-intercepts, how to find the vertex, right? So I want to go over that and make sure it's clear. So to find the X-intercept, remember you're always going to have y equals 0 and then solve for x. Right? That's going to give you your X-intercept. So that means I'm going to put 0 here, right? And then it's already factored for you, so some of the hard work is already done there. Now you just need to set each part equal to 0, right? So I'll have 7x minus 2 equals 0, and then the 6x plus 1 equals 0. And then I'll solve there. Why don't I need to set the 5 equal to 0? Can somebody just unmute yourself and tell us? Why don't we need to do that?
What was your question?
So why don't we have to set the 5 equal to 0? Because I said set each of the factors equal to 0. But why don't we need to do this?
It doesn't have the X thingy on it.
Yeah, there's no X to solve for, right? So there's nothing to do here. So 5 doesn't equal 0, right? And there's no X to solve for, so it's just kind of nonsense. We don't need to worry about that 5 that's out in front. Just set the other two parts equal to 0. All right, so let's do that on these. So we'll add the 2 over. So 7x equals 2. Divide by 7, so x is 2/7. All right, then let's subtract the 1 over. 6x equals negative 1. And then if I divide by 6, x equals negative 1/6, right? But then I want to make sure that I'm writing my answers as ordered pairs. Okay, now on the test, on that number 1 on the test, I was really lenient and I didn't mark off points if you didn't write them as ordered pairs, but on the final exam, I have to take off points because everybody, like, we've got to score things the same way so that, you know, each instructor is scoring things the same way. So I just want to warn you on that. And in the directions, it said in bold letters, make sure all intercepts are written as ordered pairs. Okay, same thing on the final. You've got to write them that way. All right, so we'd have 2/7, comma 0, and then -1/6, comma 0. Okay, let's talk about the vertex also. So in this form, remember that the vertex, the way we find the vertex the easiest is it's halfway between our x-intercepts. Right? So we have to find what that halfway point is because that's going to tell us what our x-coordinate is. Right? So if I find halfway between this, and this is kind of a, you know, not a very fun one to do, but we'd add the 2/7 together. Right? So 2/7 plus a -1/6, and then we'd have to divide it by 2. It's going to give me some kind of crazy number, but on the test, it's not going to be that way, right? Let me see here. I'm not even sure if it's worth, like, trying to do this one since it's just kind of weird, but anyway, so, but that's what you need to do on this to be able to, and then, yeah, and it's just going to give you, you know, a crazy fraction like 8 or 5, you know, so x equals 5/84, right, is what's halfway between there, okay? It's not going to be that crazy on the final, but I just want to make sure that you see that, you know, that's the way that you can find that halfway, or that vertex, is it's the halfway point between there. And then you take whatever you get for x, right, and you put it in place in your, you know, so we know that y equals 5 times 7x minus 2 times 6x plus 1, right? So we take this, right, and we put it in place of both of our x's, right, and then solve it out. I'm not going to do that because it's going to get so lost in the fractions and stuff like that, and it's not going to be, you know, very beneficial, I think, for what it is. But there will be some other ones that will be better to kind of look at for that. Okay, but look at the one on the test. You know, if there's something on the final, it would probably look very similar to that, right, and be kind of in that way. Okay. All right. All right. Thank you guys for answering people's questions that they have on where we're at. Yeah, we are doing that lab 14. So that I talked about at the end of class last time to help review for this. Okay. All right. What about this one? I want you to look at this part I, and I want you to tell me, just by reading through here, what type of function it is and how you can tell what type of function it is just by what's given here. Okay, anybody have an idea? What type of function do you think it is? Either unmute yourself and tell me or type it in the chat. What do you think?
Is it exponential?
It is exponential. Why did you think exponential?
Because of the percentage change.
Exactly, right? So when you see a percent change, right? So it's a percent change each day, right? So this is giving us, you know, this rate that we've talked about before, right? So that percent should be kind of something that clues you in that, oh, this is exponential, right? And then this is our start amount, right? At the start of the test, there's this many bacteria. it decreases by 13% each day. Right? And then, so how would we write a rule for it? Right? I'm not going to use I of x. It just looks weird. I'm just going to use y. Okay, so y equals, right, we want it in that form of y equals a times b to the x power. So what's our start amount? 100 million, right? And you could just put it as 100 here, but then remember that it's, you know, when you're talking about this, that it's in millions, right? So you'd have to, you know, make sure in your answer you put that millions back on there, okay? So 100 in millions times our percent, right, is that 13% each day. But we're not going to put 0.13 in there. Let me underline that other part. It's saying it decreases by 13% each day. So how do we decide what goes in here according to that? Decreases by 13% each day. Okay, what do you mean by 100? So, oh, maybe you, sorry, you probably were answering the last one. The start amount was the 100, right? But the, so 1 minus, right, 0.13, okay? Yeah, which is going to give you that 0.87, right? Sometimes people get kind of confused on where that 0.87 is coming from, but remember, you're taking like that, you're taking 100% and minusing off 13%, right, which is going to give you 87%. That's how we're getting there. So y equals, whoops, and that should be to the x power, 100 times 0.87 raised to the x power. Right? And so that would be this, when it says write an algebraic rule, right, then you got to remember that that's saying that you're just writing an equation, right? So, so one of the things that I would say to make sure that you put on your, like I said before, like let's make up a paper, like make up some notes that you'll have handy, because remember this one's going to be timed. And your last tests haven't been timed. And so sometime, well, I guess the one in class was, but you've got to make sure that you are prepared and have everything together that you need. And so I would put, you know, some of those things on there would be, you'd want to have this, that it's your exponential equation, and then put in that this is your start amount. And this is your percent change, right? And so just writing some of those things down, and then do the same thing for linear, right? And write those things down. And so, you know, maybe even today as we're going along, it would be good to have like another sheet of paper off to the side to jot some of these things down on, because you don't want to have to be, you know, oh, where was that in the book? Oh, where, you know, how can I find this, right? Because you're not going to want to take that time to do that. Let's, you know, be prepared up front so that you're not stressed about it when you're actually in the test. You have things there. Okay?
This final exam will cover everything that we've learned in class.
It is, yep. Yep, so from everything from the start till what we just barely learned about circles and the, you know, Pythagorean theorem and, you know, and all that stuff. So yeah, so everything is going to be on here. Okay, so that's why I said, like, that's a lot of material. You're lucky that you actually get to use your notes, though, because usually on most semesters, right, they don't let you use your notes on this final exam. So it actually is, you know, quite to your advantage. But make sure that advantage is helping you, right? Be organized with everything so that it will be an advantage, and not you just frantically trying to look through your book and you can't find things, right? All right, let's see. I'm going to skip down to K now. So what kind of a function is this, and how can you tell? So we're looking at the graph now, right? So there's a lot of different representations. Okay, so Luciana says it's a logarithm, right? And how could you tell that was a logarithm?
Just the shape of the line.
So how could you tell it wasn't a square root graph? What's the difference between, because it looks pretty similar to a square root graph, but how do I know it's a logarithm? Well, remember that logarithms are going to have an asymptote, right? Square root graphs do not. So it's kind of hard to see on this one. It doesn't stop there, but it kind of looks like it stops there, right? But on the test, it'll make sure it's really clear to you that it's, you know, it might be getting really, really close there. Okay? So, so that shape is the logarithm. And what would our asymptote be here? Okay, so the y-axis. Okay, or you could call that x equals 0. And some of you on the last test, you put the y-axis and then you put or y equals 0, right? But it's not y equals 0 is a horizontal line. X equals 0 is the same thing as the y-axis. So just be careful on that also, right? Which one you're picking there. If it's easier for you just to say, you know, which axis is it, great. You can put that. Okay. All right. Okay, so this one is quadratic now, right? And so if we're looking and trying to compare the difference here, right, it's kind of moving at, it feels like at almost the same kind of rate, and it looks similar to it, but notice that it stops there, right? It does not go any further down here, because remember we said with those, you know, your domain is limited, because this is going to have some kind of a square root in it, right? And so if it has a square root in it, then you can't have a negative number inside that square root. So last time we kind of talked about that domain, a little bit like how you figure out the domain of this. And so it can't be anything, like we are not going to get any answers for anything that is bigger than -4, right? Those are all going to be imaginary, and we can't graph those imaginary solutions on this grid because this is with the real numbers. Okay, so just notice those slight differences there. And it's going to be an important thing. All right, what about this one? Okay, what kind of a function is this one? Okay, Rachel says quadratic, question mark. You're right. How do you know it's quadratic? What made you think that, Rachel?
It's got the vertex at the bottom and then it goes up forever.
Yeah, and it's a U-shaped graph, right? Remember I said in 1050 you guys will talk about graphs that are V-shaped, right, that come down at a sharp point. And so I want to make sure that when you're graphing these, you know, you remember it's going to be this U shape. It's not a V shape to it. Okay, so yeah, we can find out some things. I mean, so writing an algebraic rule from this, right, is, you know, is actually maybe a little bit easier than you would think, because if we can tell what those X-intercepts are, right, then we can say, all right, I'm going to write this in factored form, and that's perfectly fine, right? So this is at 1 here, right? My x is 1, and here x is 5, right? But how would I write that as an algebraic rule? How would I use those? Do you remember? Okay, so those, yeah, so those are our 2 points. So yeah, we want to say, so we want to write it as x minus 1 in one of the sets of parentheses, and then x minus 5 in the other. Because remember when we undid that, we were saying, okay, when I solve these, right, I'm going to do the opposite of what's in there, right? And so when I solve this, x equals 1. When I solve the x minus 5, right, x equals 5. So you're kind of like doing the opposite of those in there. Okay, and you could like FOIL those out if you wanted to have it in standard form, but this is perfectly fine with me. This is an algebraic rule that satisfies this equation. Okay, and then what would the vertex be? That's not part of the algebraic rule, but it might ask you to find the vertex of this. Well, that's just over 3 down 4, right? So 3 comma negative 4. So another way that you could have written it, though, would have been in vertex form, right? So you could have used the vertex instead. And so you could have had it as y equals x minus 3 all squared, right? And then, whoops, minus 4. Right? And even though these guys look different from each other, they're actually the same. Okay, so it wouldn't matter to me if you wrote the equation looking like this, or if you wrote it in vertex form looking like this. Right? Both of them can do it. This one you're using the X-Intercepts, and this one you're using the vertex. Okay? But both of them are great ways to write it. Okay? All right. Awesome. I appreciate you guys, responding and, like just keep writing things in the chat. I know sometimes it's like awkward to try and pause, unmute yourself and then mute yourself, but, I love hearing your voices too. So if you want to do that, it'd be great. Okay. And I'm going to skip over this page because we did this last time in class where we went through and we talked about all the different shapes of these graphs. All right, so at the very end of our lesson, we talked about those. So we already did those and should be in your book. If you weren't here last time, then I suggest you make sure that you go through the video that I posted on last time's stuff. Okay. All right, so another important thing that you're going to want to make sure that you know how to do is solve, right, different types of equations, right? And I want to try and give you a little bit of time. We talked about some of these last time too, right? And so I want to give you a little bit of time right now to work through these 5 equations, okay, and try and solve them there. All right, so you're trying to figure out what x is. So if you need to look back on the notes that we did from last time in the book, then I would do that. But try and see what you can do without looking. Maybe you need help on, one of them or something like that. But try and see what you can do without looking first, because that's going to stick in your brain better and you'll be more ready for the test. Okay, but if you need to look back, if you can't do anything in there, then look back and see what we did and then start it. Okay, so let me give you, about, I don't know, maybe about 7 minutes or so. See what you can get done in that time. And if you guys want to unmute yourself or talk in chat, like about, oh, I'm so stuck on how to do this one, please just unmute yourself and ask each other, okay? Positive. Plus or All right, let's maybe start looking at this. See how you guys were able to do on these. All right, so on this first one, we see that we have a square root. And so remember that last time, a lot of the stuff that we covered last time is really going to help you for the final exam. So we talked about if there was a square root and it asked you to solve it, then you need to remember that you need to square both sides. But we can't do that yet. We got to get the square root part by itself first before we can do anything there. All right, so when I do this, all right, I'm going to start by adding 6 over. All right, and then, sorry, this is the one. Right. What do we have here? Tell you there's just way too much. Oh man, my life these days has been crazy, crazy. All right, so let's add these together. So 29 plus 6 is going to give us 35. And then I'll have 7 times the square root of 3x minus 1. And so now, to get the square root by itself, I've got to divide both sides by 7. All right, so now I have the square root of 3x minus 1 equals 5. So now that that square root part is by itself, right, now I can square both sides. And I'm squaring this so I can undo that square root, get that number, because I'm trying to solve for x, but it's stuck inside that square root. All right, but whatever I do to one side, I need to do the other, so I'll square the other side. Then I'll have 3x minus 1 equals 25. And then I'll add the 1 over. All right, so 3x equals 26. And then I just need to divide by 3. So x equals 26 thirds on that one. Okay. Questions on that one? Are you able to come up with that? Were there some things that you did in a different order? Not quite sure why. I did things in the order I did there. Okay, well, let's go on to the other one then. Okay, let's speak up if you're not quite sure. All right, what about solving this log? So same kind of thing. I need to get the log part by itself, meaning we underline this part. I want to get that part by itself, right? And I want to do that because remember, to solve logs, I need to put it in exponential form. So I've got to do that thing, but I have got to have the log part by itself first, not just the log. All right, remember that's an operation. We can't have that completely by itself. We need the log of what, right? So we're going to move the other stuff over. So let's start by adding the 6 over. All right, so we get 7 times log base 2 of 3x minus 1 equals 35. Okay, and again, it's connected by multiplication here. So we want to divide by the 7 to get rid of that. All right, so I'll divide by 7 on the other side. So now I'll have log base 2 of 3x minus 1 equals 5. All right, and now that this, this part is by itself, the log of something, now I can put it in exponential form, right? 2 to the 5th power equals everything inside the parentheses there. All right, so I've got 2 to the 5th power equals 3x minus 1. 2 to the 5th power is 32. And then I'll need to add the 1 over. I'm running out of space here. Let me put it up here. So I've got 33 equals 3x, and then just divide by 3. So x equals 11 on that one. Okay. Awesome. Okay. How many of you by raise of hands were able to get 11 on that? Will you just click your hand button so I can see where you guys are at? Nice. You guys are doing awesome. Okay, let's try. I'm not going to do both C and D. I'm just going to do one or the other. Is there one that was trickier than the other for you to try? Do you guys have a preference whether we do C or D? I guess we might solve these a little bit differently. Maybe I'll just quickly do both so we can see. So we're going to start this out still the same way, right? So I've got adding 6 over. Oops, it's hard to see. Remember, this is the power. That 3x minus 1 is the power, right? And 35. Again, we've got to divide by 7 here. Right? You don't want to multiply. You can't do 7 times 5 first, because remember with our orders of operations, we have to do our exponent before we can multiply, but we can't do our exponent because there's a variable there, right? So we're trying to undo this to get x by itself, so we got to go about it this way. All right, so then we have 5 to the 3x minus 1 power equals 5. Well, now our bases are the same. So when our bases are the same, we can set our exponents equal to each other. So this really says 5 to the first power. They don't put that invisible 1 in there sometimes, right? But we know it's there, and now we can just say 3x minus 1 equals 1. And then we'll add the 1 over, and then divide by 2. So x equals 2/3. On that one. Okay, so you can do the like bases on this one. So if you did it differently by taking the log of both sides, that's fine. You could still get here to this answer, right? But it's just faster if you can see that the bases are the same to just set those exponents equal to each other. Okay, but on this one, right, we'll still start it off the same way. Let's add the 6 over. So we got 7 times 2 to the 3x minus 1 power equals 35, right? And then let's divide by 7. And so then that's going to give us 2 to the 3x minus 1 power equals, well, we've got 35/7, right? So, well, that's going to be 5. And now we can see, okay, my bases are not the same, so I can't do the same thing that I did over here on part C. Right? I can't get my bases to be the same. So in order to do that, I've got to take the log of both sides. I'm just going to move my 5 over a little bit so I can write my word log in there. All right, so I'm taking the log of this side and taking the log of this side. And remember, I'm doing that so because one of the properties of log says that if I'm taking a log, that exponent can come out in front and be multiplied, right? So I'm moving it down to a place where I can actually solve for x. I can't solve for it when it's up there, right? So that's what I'm trying to do here. So that gives me, just write it down here. So I've got in parentheses 3x minus 1, then times the log of 2, equals the log of 5. Right? And so to get x by itself, let's first divide by our log of 2. Just trying to move things around to be able to do this, right? And then go ahead and put that in your calculator right now, right? I put in there log of 5 divided by log of 2 equals, and it's going to be this big long number. Right, but that's fine. Keep it in your calculator. Then you'll want to add your 1 over. Right, so add 1 next. And then the last thing that you're going to want to do is divide by 3. So we'll do all of that divided by 3. Right. And then let's just round this to the nearest tenth on that. Okay. You see, what answers are you getting for this if you rounded it to the nearest tenth? enter that into the chat. I think we're going to get there. Okay, so Monica, what would that be rounded to the nearest tenth? Okay. Right, so 1.1. So again, watch that on the final, because that's one of the things, again, I'm going to have to mark off for. If you don't round to the place value that it's asking you to round to, you're going to miss points there. Okay, so really watch that closely. If you get a really big long number, right, that should clue you in of, oh, okay, where am I supposed to round to? Look back in the instructions. Okay, to the 10th, to the 100th, whatever it's telling you to round to. Okay, so, all right. And then let's see, there's one more here. Let's try this part E also. All right, let's see how you guys are doing with this. So again, we'll start by adding the 6 over. All right, so we've got 7 times 3x minus 1 squared equals 35. Then we'll divide by 7. Okay. So 3x minus 1 all squared equals 5. And now how do we undo squaring something?
Square root the other side.
So I've got to square root this side because the square root and the square cancel out, but then that means I need to square it the other side as well. So that will leave me with 3x minus 1 equals not just square root of 5, but plus or minus square root of 5. Right? Remember that you got to have that plus or minus. Then let's add the 1 over. Right. So I'm going to have it as 3x equals 1 plus or minus the square root of 5. Right? And then we'll divide by 3. And so that would be your answer. Okay. And on your on the last test, also there were some of you that were writing this the other way. I would encourage you to write this 1 first. And like I said, sometimes some calculators will write it the other way, but it gets a little bit confusing. Like if you have plus or minus square root of 5 plus 1, I mean, it just looks kind of weird, right? And sometimes people had it so it looked like that square root was including that plus 1, which it doesn't. Like their square root kind of went out further than it was supposed to there, okay? So just be careful on that. This is still correct, but it's just easier if you have when you bring that number over, when you add the number over, put it in front of that plus or minus sign. Okay?
I have a question.
Yeah.
Question. So, how, because I know there's one of like those on the test. Well, not like those, but like the plus and minus. When I did it both ways. So I did 1 plus the square root of 5 or 1 square root of 5. Is that an okay thing to do or no?
So doing it which way? So if you did 1 plus the square?
You know how it says it's equal to 1 plus minus square root of 5?
Yeah, so that means 2 different things, right? So you're going to have one answer that's going to be 1 plus the square root of 5, and then divide it by 3.
Yeah, that. And then 1 is 1 minus square root of 5.
And then I want you guys to also, let's change these to the decimal approximations too, right here. So let's round these to the nearest tenth so we can kind of get some practice with it. Because also what I noticed on the last test is some of you were getting here, but when you did your decimal approximation, you missed it. So you might be doing something wrong with your calculator. So I want to make sure you got that right. Okay, so maybe this one's going to be about 1.1, right? And then on this one, is going to be negative 0.4. Right? We're rounding those to the nearest tenth. So it doesn't matter if you put it into your calculator as square root of 5 plus 1, right? But if you put it in backwards on this one, then you have to put negative square root of 5 plus 1, right? Because whatever sign is in front of it, like, is stuck with it. So it's another reason why I think it's just easier to put it in this way. And like I said, some of your calculators will like change it to the other order, and it's the same thing, but then just make sure you change it to decimal and do that from there. Okay, does that help? Did you get those answers on here? Can't remember who was asking me a question last time. Sorry.
Yeah, I did.
Okay.
Yeah, I did.
Awesome. Okay, yeah, it looks like you guys got the 1.1s and then doing it the other way, right? That negative 0.4. So we should come up with the other one. Okay. All right, let's see, what time is it? I think it's about time we should take a little break. And then when we come back, we're going to be doing the review that the math department puts out. And so we've already reviewed through some of it here. And so I'm not going to go through everything on there, but I'll go through the stuff that need to make sure that we, review over for the final exam. Okay, but let's take a little 5-minute break, get up, stretch and stuff. I need to go get some water. Okay, break time. Braxton, are you going to do some breakdancing for us during break time? Come on. Or some singing. Either one. All right, so some of this is going to be a little bit of review from what we've talked about in the other review, so I'm just going to kind of skip through some of this and just make sure we get the most important parts here. But just make sure that you know how to graph different types of functions is one of the most important things on there, right? And you can always make an XY chart like this to figure out what the graph looks like. All right, pick your X's on this one. Oh my goodness, that's a big yawn. Pick your X's and then figure out what your Y's would be. And so on this one, we'd want to pick out, and I want to kind of talk about this one as well because there was something similar to this on the last test, but some of you were thinking that it said square root of x minus 2 inside, right? That minus 2 is not inside there, so watch that closely when you're doing your graphing on the final, because that means something totally different. Right here, you're taking the square root of x, then subtracting 2 off. Here, you have to subtract 2 first, and then take the square root. Right? So two totally different things. So make sure you watch which way that's being written. And if you're writing it down on another sheet of paper, especially make sure you copy it down correctly. Right? So we want to pick numbers that are perfect squares on this one because we're taking the square root of that number and then subtracting something off. All right, so I'd want to choose, well, let me ask you this. Can I pick any negative numbers? Right, so could I do -1? All right, well, the square root of -1 is I, right? Braxton's like, no, right? We can't use those. We can use 0 and bigger on this one, but we don't want anything inside there, right, with a negative. So let's pick 0, 1, 4, right, and maybe 9, something like that, so you can see what this looks like. All right, so I put 0 in there. Square root of 0 is 0 minus 2 is -2. All right, put 1 in. Square root of 1 is 1 minus 2 is -1. Put 4 in. Square root of 4 is 2. 2 minus 2 is 0. Put 9 in. Square root of 9 is 3. 3 minus 2 is 1. Okay. So, and then we're just going to plot these points on here. So over 0 down 2. Over 1 down 1. Over 4. 1, 2, 3, 4, down 0, and over 9, up 1, it's going to be out here somewhere, right? So it'll look something kind of like this. This is what that graph should look like. Okay? So just make sure that you kind of, and remember, it stops here, right? We can't have negatives inside the square root. So we're not going to have, our graph just, it doesn't have, there's no other x's. Like in the negatives there. Starts here and then goes to the right like that. Okay? All right, so just be careful of that. I wanted to bring that one up since we had one on the last test and there were some people that missed that. Okay, let's do this number 4, part A. So in this one, it's just asking us to find f of -3, right? And it gives us this function. So it's basically just saying, take -3, right, and put it in place of x, right? So here, if we do that, right, we've got f of x, right, on this, and we're putting -3 in place of our x. So I've got that negative, now be careful on the way you write this, right, negative, and then in place of x, let's put parentheses where our x is, right, -3 is going to go inside there. And then that's going to be squared. Right? And then -4 times -3, and then plus 2. So be careful with those parentheses, right? Because -3 squared like this is not the same as if you have the parentheses around it. All right, so go ahead and put that into your calculator. Let's figure out what you come up with here. Awesome. Hey, that's what I came up with too. 5. He's got. But if you accidentally made that -3 squared and -9, right, you wouldn't have gotten this for your answer. So just watch those signs carefully on the final. Okay? So that's taking us clear back to like the first week of classes, right? We've talked a lot about graphing, you know, and stuff so far, making those XY points and stuff, and, you know, the slope and the Y-intercept, what those things mean. But we haven't talked about yet finding an equation of a line. So let's do one like this. It's been a while since we talked about this. All right, remember that we have this y equals mx plus b, right, is our equation of a line, and that's what we want to get it to look like. We want it in slope-intercept form. So we're given 2 points on this one, and so for this we also need to remember that slope formula. Remember when we were finding the rate of change? Right, so let me write it here. So rate of change, right, or we also call it slope. Right. We said that was going to be the change in y over the change in x. Right? Or you can think about it as, you know, y2 minus y1 over x2 minus x1. Right? And so if I name these things here, different, so this would be my x1, y1, and my x2, y2. Right? So I'm finding, so there's my points, and then I'm going to use that slope formula, right, that rate of change formula, to help me figure out what this slope is going to be. So let's do that first. So my slope is going to be 9 minus 1. Make sure you have your y's on the top. Right? Not your x's. Your y's have to go on top. So 9 minus 1 over 8 minus 6. All right, so simplify this. I get 8 on the top, I get 2 on the bottom. Divide that out, I get 4. All right, so my slope is 4. So I've got part of what I need. All right, I can put that in here. All right, now I need to find my y-intercept. And so to find b, remember I'm going to use one of my points here and put those in place of my x and my y. All right, so I'm going to use this x1 and y1. All right, so in place of my y, I'm going to put 1. In place of my slope, I just found that to be 4. In place of my x, I'm going to put 6. And then I don't know what b is. That's what I'm trying to find. So let's simplify this. 4 times 6 is 24. And then I need to subtract that over. Negative 24, or negative 23, I mean, is what my b is. Right? So now I have my y-intercept. Right? I have my slope. And so I'm going to use those two things to put into my slope-intercept form. So I'm going to write this again down here just to make sure you're with me. Right? So negative 23 is going to go in place of b. 4 is going to go in place of m. So y equals 4x minus 23. So that would be the equation of a line that's going through those 2 points. Okay. I know it's been a while since we've done that, so what questions do you have for me there? Learn how to do that. So again, 2 more things that I would add to that paper. Make sure you know this slope-intercept form, and make sure you know this slope formula, and the rate of change is the same thing as slope. Right? Those would be good things to put on that sheet that you're going to have with you, right, to keep all of your important formulas and information on there. Okay. All right. We are going to, now let's start talking about systems of equations too. It's been a little while since we've talked about these. So you want to make sure that you know how to solve by substitution, elimination, and also solving with matrices, right? So we want to make sure that we can do those, you know, all that way, because that's going to make it a little bit easier. So let's do a few of those different things. So remember, with substitution, you need to get one of the equations, like one of the variables by itself in one of the equations, right? So, gosh, this one isn't going to be super fun because it's going to have a lot of fractions in it. I'm not going to do that on the test. Maybe we'll just remember that you would just be putting, you know, you would substitute that back in. Gosh, all of these that they picked on here are really not very good. So maybe I'll find one that, you know, is a little bit better and stuff that we can do. Maybe even if we just change this to be y equals this 10x plus 1, right? We just change it to that. And so that means we take this 10x plus 1, and then we just substitute it in place of y in the other one. Okay, so let me write these over here. So this is number 10. Some more space over here. So 5x minus 2 times that 10x plus 1 equals 6. Right, and then we'll distribute through. So 5x minus 20x minus 2 equals 6. Get these together. That's negative 15x. Then you need to add that 2 over. Equals 8. And then we're going to get kind of a nasty fraction here again, right? Like I said, on the final, they're going to make the numbers work out really nice. So, you know, if you're coming up with really weird fractions and stuff like that on these systems of equations, you probably need to recheck what you did there, right? And then to find, so this is what x equals, right, on this, so 8 over negative 15. And then we need to take that, put it in place of y to figure out what y is, right? So y equals 10 times that x plus 1. All right, so again, it's going to give us kind of some crazy numbers here. We've got 80 over negative 15, and then plus 1. All right, so that and so it's going to end up being like negative 13 thirds or something. All right, so anyway, like I said, don't stress about like the fraction part of this. It's more of just, do you know how to do the substitution method? And it's not that you need to know how to do, you know, the different types of method. The only one that's going to be asked that you have to do it a certain way is there's going to, or at least there's usually one that says that you need to do it by matrices. And so if it says to solve it using matrices, you need to do it that way. But otherwise, you can just kind of pick which way you're going to solve it. Okay, so unless it says a specific way, it's all right. Okay, let's do, I wanted to do this, this solution one here with the 30% solution, 15% solution. All right, so trying to think here. Everybody, I might just erase this. Maybe I'll just put this up here. So that I have a little bit more room down here to do this. Okay, so let's look at that number 11, but specifically on number 11, that one with the percent solutions. Okay, so the pharmacist is let's see, she receives an order for 300 milliliters, right, of a 30% antibiotic solution. She has a sufficient stock of 15% and 50% solution, but does not have a 30% solution on hand, right? How much of each does she have to mix together to get 350 milliliters of the 30% solution? All right, so remember when we did these together in class, I kind of set it up as a little chart to try and organize the information. It's up to you if you want to, use a chart or not, but I think it's helpful. Along the top, you're putting things that you're mixing, right? So you're talking about, what am I mixing, right, together? Well, I'm mixing a 15% solution and a 50% solution to try and end up with a 30% solution. And then along the side, you're thinking of kind of what your units or the labels are on this. So we've got milliliters, and we've got percent, and then we've got the total. Right? And these are going to help make our two different equations so that we can, have two equations, two variables to solve these. Right? So I'm going to say that I'm going to have X be my 15% solution. So I don't know how much of the 15% solution I need. Right? I don't know how much of the 50% solution I need, so I'm going to call it Y. But I do know that I need a total of that 350 milliliters, right? So I'm putting it in this row because it's talking about the milliliters, right? So that's going to be one equation that says X plus Y equals 350, right? I don't know how many milliliters of each, I just know together they have to add to be 350. All right, and then the next row is just changing your decimals, your percents to decimals, right? So 15% is the same as 0.15, 50% is 0.5, 30% is 0.3. And then to get my other equation, I'm multiplying these together, right? So I'm multiplying these together. That's going to give me that 0.15x. Multiplying these together, that'll give me 0.5y. And then this is the part that a lot of people forget to do. So you've got to multiply those together. So what's 350 times 0.3? All right, that's going to be 105. So now this is our second equation, right? So our other equation is going to be 0.15x plus 0.5y equals 105. Right? And now you're just going to use either the substitution or elimination method to solve these. All right? And I'm going to use the elimination method on this one since we did the substitution method up there. So remember with the elimination is you're trying to think, okay, if I add my equations together, right, and they have to be in that form where they have x's and then y's and then the whole numbers on the other side. Right? So the way I have this set up is important. Right? But do you see I could multiply my top equation by 15 because if I do 15, sorry, I didn't mean 15, I meant 0.15, right? And I want it actually to be negative there, right? Because I want this, I have 0.15x, and if I subtract off of 0.15x, then those will eliminate. So that's why I'm doing it this way. Okay, so I'm going to distribute negative 0.15 through on this. Okay, but like I said, if you like the substitution method better, you could go through and solve this using the substitution method also. Okay, so I've got negative 0.15x, and I've got negative 0.15y equals, right, well, what's 1.15 times 350? Right, it's going to be 52.5 and it needs to be negative, so minus 52.5. Right? Okay, so now we're to the point where we can combine these together. Right? So I see that my x's eliminate out. Right? I was doing that on purpose. Right here, 0.5y minus 0.15y, right? So we've got to subtract those, and then we're going to divide there. So let's have you guys try and figure out the rest of this. So figure out what you come up with for y, and then do that back substitution. See what you come up with for x. Okay, so I'll give you a minute to try and do that. Okay, so did you guys come up with 150 milliliters for the 50% solution? Actually, maybe I'll just make sure that it's really clear, right, on this. I need 150 milliliters of the 50% solution. Right, that's all going to be part of my answer there. Make sure I know which one I'm talking about. All right, and then I'm going to take that 150. And it'd be easiest to put it back into that first equation, this top purple one there, right? So I'll have x plus 150, right, goes in place of my y, equals 350. So really all you're doing is you're just subtracting that 150 off, right? So then x equals 200, right? So 200 milliliters of the 15% solution. Okay, is that what you guys came up with? You have questions about how to get there? You're remembering some of this? I know sometimes it's like, whoa, seems like we did this forever ago.
Good morning. I'm just logging on, but I sent you an email this morning asking if this
Of
was
course.
recorded as well,
Yeah,
so I could go
everything's
back.
recorded.
Okay.
Yep.
Okay. I'll just double check.
Yep.
Okay. Thank you.
All right. So let's look at some of these. Let's do one of the 3x3 equations there in number 12, because we need to make sure that we know how to do those type 2. Let me see if I kind of scroll down here and do this. So let's do this second one here. Okay. So I'm just going to write that over here. So I have one of my equations, okay, is going to be negative x minus 2y plus 4z equals negative 29. Then 2x plus 4y minus 8z equals 58. And then the last equation, equation number 3, on there is 3x minus 4y plus z equals 2. All right, so remembering back, right, does anybody have an idea? You share with us how will we start to solve this? What should we do first here? Nobody remembers.
It's the one where you choose like either the middle terms or y and see if you could. I don't know how to explain it, but I know what we have to do.
It
It's
is,
hard to
it is,
explain.
right? Sometimes like just trying to put things into words. Well, what if I choose, so let's say I'm going to pick equation 1 and equation 2 that I want to look at first, right? Then I want to be able to eliminate one of my variables in there, right? So that means I'd want to multiply that top equation by 2. Because if I multiply this all by 2, then I'll get a negative 2x, and I'll add it to that 2x, and they'll eliminate. Right? So that's what I'm going to do first. So equation 1 is going to change to be negative 2x minus 4y, right? And then plus 8z equals negative 58. And look at what happens when I add that to my other equation here. All right, what's going to end up happening on this one?
It just cancels each other out.
It just cancels each other out,
like
basically.
The x's are gone, right? The y's are gone, the z's are gone, so I'm really left with 0 on this side. And then on the other side, I also get 0. All right? And so remember, if you come up with something like this, 0 equals 0, that means that it's infinite solutions. All right? Where if it was 0 equals some other number, that would be a no solution. Okay? Or a DNE, does not exist. Okay? Something like that. So, so just make sure you understand, how to, look at that and stuff and tell if he comes up with something like these, whether it's infinite solutions or no solutions, right? So let's see. So let's take a look at number 12 also, because we probably want to make sure that we know how to do this one. I wonder if I can fit it, this first one here, right underneath here. And then I'll save this, because I want to do this, the matricey one too, right? But let's see, let's fit it in here. Okay, so on this one, right, again, we've got 3 equations. Maybe I'll have you try and start this one out and see what you think you would do here, right, according to what we talked about on this first one. Got a very unhappy boy who's crying in the background. I don't know if you guys can hear him. He's so sad. Homeschooling has not been a joy. I know some of you can relate. Okay, so on this one, I would look at it and I would actually, instead of getting rid of my x's, I can see that my y's are probably going to be easier to get rid of right off the bat. Right? So if I look at equation 1 and equation 2, and if I were to add those together right now, my y's would automatically eliminate. And so that's the route I'm going to go on this one. Right? Because that's where I would start. Let's see. Right, so then when I do that, my y's are gone, but then I'm left with negative 15x, right, plus 6z, 5z plus 1z, equals 0. Okay, and it's okay that that equals 0. Right, and then we'll call this equation 4. right? Remember, like we done before. And now I need to go back up to my original 3, and I need to look at two other of the equations. So I did 1 and 2 before. So now I'm going to do 1 and 3, because again, I'm looking to eliminate the y. I have to eliminate the y's on both of these. Okay, so if I have, so equation 2 is negative 10x plus y plus z equals 3. Oh no, wait a minute. That's not the one I wanted to do. Sorry, guys. Keep hearing my son in the background. That's my husband's with him. He's just not a happy camper. All right, so let's try this again. So we're going to do 1 and 3. And then 3. So then on this one, right, we get 15x plus 7z equals 0. Okay? And now we're going to use our equation 5 and equation 6 and try and eliminate another variable. Right? So
Is that supposed to be 15x?
yes.
Okay.
Does that know what it looks like? Sorry.
What is now equation 5? I just see 15x. I didn't know if it should have a
No,
negative
it's
in
not
front of
supposed
it.
to have a negative because we have negative 5 plus 20 gives us a positive 15.
Oh, sorry. Okay. Sorry. Yes, you're
That's
right.
okay.
Sorry. Okay, thanks.
Right? And so now these are my two equations. So now I'm going to just put, you know, the one underneath the other. So I'm going to put 15x plus 7z equals 0. And this one works out nice too. Those x's already, right, are eliminating. So then you're left with 13z equals 0. And when I divide by 13, that's not going to change anything. 0 divided by anything is just 0. So I know that my first answer is going to be z equals 0. Okay? And so remember how we put in different color up here. Whoa, what's going on? Okay, something crazy is happening. I hope it's not going to wig out the rest of the time here. Okay, so remember that we want to write it as an ordered triple, right? Our x, our y, and then our z. So we found z is 0, so let's put that in here. Right, but then let's go through now and we can find our z. We said, okay, I know z is 0, so I can put that 0 in place of z there. Right? That's going to give me 15x plus 0, right, equals 0. Right? But now we have 15x equals 0. So x is 0. Okay. And then our last one is going to be y, so we have to go back up to one of our original equations and put our x value in and our z value in to solve for y. So I'm going to just use equation 2. This is the one I'm going to pick. Maybe I'll do it in a different color here. Okay. This one. So negative 10 times 0, I'm putting my x in place of the, or the 0 in place of the x, plus y, that's what I'm trying to find, plus z, which is also 0, equals 3. All right, so then this goes away, that goes away, I'm just left with y equals 3. Okay, and so that would be my ordered triple, right? So just remember that when you're solving these, and if you're like looking at this going, oh man, I need a little bit more, you know, help on these, right? Or, you know, a little bit more practice, you know, go back and look at these type of questions that we did before and work through them and just make sure that you know how to do those. Because remember, you always have to eliminate the same variable, right? We eliminated the y's when we looked at the first two, and then we eliminated the y's again, right? When we did those second two equations, when I did equation 1 and equation 3. and then use 4 and 5 to eliminate another variable. And then once you find one answer, you can kind of, back substitute in to find the other two answers. Okay. Remembering that? Is that kind of looking familiar? I know some of you are like, oh, it's just been so long, right? So, but that's why we're reviewing over these. These are going to be good ones to make sure you know for the test. Okay, let's look at this. I know I kind of covered up some of that. Sorry about that. Let me rewrite it over here. So if we're writing this in like a matrix form, all right, we just want the coefficients on here. So there's a 1, a 2, and then on the other side is an 11. And then on my second row, I have a 3 and a -1 and then a 5. All right. Maybe I better erase that part so I can see that better. Okay. Make sure that was what I had there. Okay. So remember that with matrices, you're trying to get it to look like the 1, 0, 0, 1. And then when you do that, you're going to have, this is going to be your answer for X and then your answer for Y. All right, so your answers are going to be on the other side of this dotted line once you get it in that form. And remember how he said it's good to go in a certain order, right? So make this first one a 1, and then go down and make that one a 0, go over, make it a 1, and then go up and make it a 0. So kind of make this little U shape, right? Is going to be the fastest way to do these. All right, so we already got a 1 in the upper left-hand corner. Yay! Right? Don't have to do anything there. But now I want to go to my next part, right? And I've got to think here, okay, how am I going to make that 3 into a 0? Does anybody remember? Be willing to share with us? How would we make that 3 into a 0? Because that's what I want to do next.
Is this where you can multiply the top by -3 and add
exactly.
the second row?
That's exactly right. So you're looking at, okay, what's the opposite of 3? That would be -3. Then it times it by row 1, and then add it to row 2. I thought I had enough space over here. Let's see, move this over a little bit more here. So yeah, so when I do that, right, negative, so remember, nothing is changing on my top row, right? I'm multiplying the whole thing by -3 just so that when I add it together, right, I can eliminate what I need. So I'm just kind of doing this in my mind, but nothing is changing on row 1. All the changes are happening to the row that I'm adding to. All right, so -3 times 1 is -3, plus 3 is 0, which is good. That's what I was trying to get there, was a 0. Right? Then let's do the next one. Right? So -3 times 2 is -6, minus 1 is -7. Right? Then let's keep going. -3 times 11 is -33, right? And then -33 plus 5 is -28. Right? That was a negative, yeah. Sure, put that in, right? Okay. Okay, so now we've got my 1 and my 0. Now I want to get this -7 to be a 1. Somebody tell me what you think. How would we get that -7 to be a 1? What do we need to do now? How do we make 1s? We multiply by its reciprocal. Okay? So look back to, the notes that you took on matrices and stuff, and I gave you hints about how to make 0s, how to make 1s. Right? So to make that into a 1, we're going to do the reciprocal of -7, which is -1/7. And then I'm going to times that by row 2. Right? So when I do that, Okay, again, my top row is not changing. Okay, so that's going to stay as 1, 2, and 11. Right, I'm just trying to change that -7 right now. So -1/7 times 0 is still 0. -1/7 times -7, right? Negative times a negative is a positive. So that's going to be a 1. And then -1/7 divided or times by -28. And in your mind, if it's easier for you to think of that, it's really saying -28 divided by -7. Right? That's really what you're doing there, which is a +4. Okay. All right, we got 3 out of the 4 done. Now we just need to do that last step, right? So here, right, now I'm going to use this 1 that's on the bottom, right, and I'm going to multiply it by the opposite of the one I'm trying to get rid of. So I'm going to do -2, so keep this consistent here, so -2 times row 2 plus row 1. Is the number that I'm trying to change is the number in the top row in row 1. All right, so this time let's just write down all of row 2 because that's not changing. All right, we've already figured out what y is here. You can see that y is 4. All right, I have that answer there, but let's go and do the top row so we can figure out what x is. So now when we do this, right, we've got -2 times 1. Well, I guess I can do the first one here. -2 times 0 is 0 plus 1. Keeps me at a 1 here. -2 times 1 is -2 plus 2 is 0. -2 times 4 is -8 plus 11 is 3. And so now I can see that my x is 3. Right, so those are my answers. X is 3 and y is 4. And if you have time on the test and you're like really worried about matrices, whether you did it right or not, remember you could take your answers that you get and just substitute those back in and see if those work out. Or you could try, you know, like this, solving it by elimination or substitution instead and check it that way. So, you know, think about some things that you can do, but only, you know, do that if you have time. Make sure you get through all the questions first and then kind of go back and do some of that checking if you have time. Okay. All right, what questions do you have there on matrices, or what can I, you know, help you with on that? You guys have been so quiet today. It's so hard for me to know, like, I can't see your faces. I have no idea, like, if you're getting it, if you're like, yeah, I get it, but it's just been a while, so it's just taking me a minute. Okay. All right, Braxton, well then you're excused because, you know, your mic doesn't work. But what about the rest of you? Just kidding. No, I do like to hear your guys' voices though, when I can. So, okay, let's see. Not doing any of those. All right, let's look at some factoring. There were definitely some issues with some factoring on the test that I want to make sure everybody is clear on how to do. Okay, and some of these are like way more than you need to know how to do, right? But let's look at some of these. So remember, if there's 4 terms, like on this first one here, right? So maybe I'll just label these. I'm going to change that to be y to the 3rd there, but I'm going to change those to be both squared like that. Okay, so changing a few of those around. but in ways that make them a little bit more, they're not going to ask really, I don't know, crazy stuff on the final. They realize, they're making the final. This is all of the whole semester, and so we're really trying to make sure that we just get, kind of all of the basics that you need to know to be successful in 1050. All right, so remember on this one, on part A, all right, with 4 terms, you're going to split those in half, right? And you're going to try and find the greatest common factor from the first 2 terms, right? And then the second 2 terms. So when we're looking at the first 2 terms there, you can see that our greatest common factor is going to be y squared. And then left is going to be y plus 6. Right, and then we'll do the same thing over here. 4 is our greatest common factor, so we're pulling out a positive 4. And when I do that, left is y plus 6. All right, so now, remember, you're not done yet. This isn't your answer. Y plus 6 is your common factor that you are factoring out of both of those, and then these guys are your leftovers, the y squared plus 4. And so then that would be your answer. Okay? And again, I want to really stress something else that happened on the test is when I said to factor, some of you were trying to solve it. Right? You can't use the quadratic formula to factor this. Right? You use the quadratic formula to solve it if it was like set equal to 0, but you can't, factor these using the quadratic formula. So make sure you're clear on, if I'm saying factor compared to solve, what you need to do there. Okay? So see down here in 24, these are telling you to solve. Right? And you might be able to solve them by factoring it first, but sometimes you have to use the quadratic formula or something. Okay? All right, let's go on to, so I'm gonna skip. I guess maybe we can do B, right? So B, remember when you have a leading coefficient on this that's not 1, then you have to take and multiply your 12 and your negative 15 together. So 12 times negative 15 is negative 180. All right, so on part B here, we're trying to figure out what multiplies to be 180 that adds to be negative 11. Whoops. All right, so it adds to be negative 11. So there's a lot of different factors. All right, what times what is 180. All right, so you can list out all of those and see, but ends up being the 20 times 9 on this, right? So 20 times 9 gives me 180. And then if I do 20 minus 9, I get 11, but I need it to be a negative 11, so let's make the 20 a negative. All right. Okay, but remember, then you can't go straight to your, answer here. We're going to either write it down as a 4-term polynomial or write it in, that, box method. Write it in your box at this point. So, but our 4 terms are going to be this time the 12x squared. Then the negative 11x is changing to negative 20x plus 9x. Right? I just took those and changed it to this. What multiplied to be that added to be this. Okay, and then minus the 15. Okay, and then you could solve it like we did up here by the factor by grouping, or like I said, you could do the box method, and either way is just fine. Right? But let's see what our greatest common factor is here that could divide out of these. Definitely an x can come out. A 4 can come out. Right? So if I have 4x, that's going to leave me with 3x minus 5. And then on the other part, it looks like a 3 can come out of that. and that will leave me with 3x minus 5. So again, my answer is going to be 3x minus 5 times the 4x plus 3. All right, going to think about what is my greatest common factor that's coming out. What are my leftovers? Okay. All right, so part C is going to be, this is a factoring, you know, those perfect cubes, right? And so, so when we're factoring perfect cubes, we've got a to the third power plus b to the third power. Remember when we said that's going to factor to be a plus b times a squared, minus, next, minus our a times b, and then plus b squared. All right, so this would be something else that you want to make sure that you have handy that's on that sheet of paper, so that if you're asked to, you know, factor these perfect cubes, you just kind of have this at your disposal really quickly. All right, so this time, let me write down what we have here. So it says 64x to the third plus 125. I'm going to actually just get rid of the y part. It doesn't really matter. We're not going to really have stuff like that. So let's just deal with ones like this. All right, so remember how I said you need to rewrite this so it's something all cubed plus something all cubed. And that's what your a and b are going to represent, right? The stuff that's in the parentheses when we're putting it into this formula. So we're trying to think, okay, what times what times what is 64. All right, what do we get there? What times what is 64? 4 times 4 times 4. Okay, so I've got 4. And then x to the third would just be x, right? So it's kind of like I'm doing, you know, like the cubed root. What's the cubed root of 64? What's the cubed root of x to the third? That would be x, or 4x, right? And then I'm also thinking on this one, what times what times what is 125? Or what's the cubed root of 125? That would be 5. Okay, so now I have what my a and b are, and now I just need to plug it in over here to kind of this formula to write down my answer. Right? So in my first parenthesis, in place of a, I'm going to put 4x. In place of b, I'm going to put 5. So I've got 4x plus 5. Okay. Then I'm going to have a squared. So I'm going to take that 4x, just write it up here. I've got to take that 4x and square the whole thing. So that's really 16x squared, right? Distribute that 2 to everybody. So I've got 16x squared for that first term there. Then minus, right, what my a and b are multiplied together. 4x times 5 is 20x. And then take my b and square it. Well, 5 times 5 is 25, so plus 25. And then that would be my factored answer on that. Okay. All right. I think I'm gonna maybe stop there on these. I would say, like, try and do, you know, D, E, and F and make sure you know how to do those. But I think if we got, you know, understand how to do this A, B, and C, those other ones will be good there. Okay. How much time do we have? We only have about 5 more minutes here. I definitely think it would be good to do some review tomorrow. I'll make another little, I mean, there's, you know, a few things that we still need to go through on this that will be helpful for the final exam. So, so maybe we'll stop there for today, but you guys tell me if there's certain times tomorrow when most of you would be able to come. I have a class from from 10 until 12. So it would have to be after that. Okay, so the final, and I'm going to write this in an announcement for you too to make sure everybody has it. I said at the beginning here, but you'll be able to pick a time on Monday, Tuesday, or Wednesday of next week to take it, right? And there's 2 different parts to it. There's a Canvas graded part that's going to be, 45-minute time limit, and then there's going to be an instructor graded part that's going to be 90 minutes. But I'll give you some more information about those, right? But yeah, these are going to be timed, but you will be able to pick when on Monday, Tuesday, or Wednesday you want to take the test, okay? So, anybody have any suggestions for tomorrow? Are you thinking you probably wouldn't be able to meet tomorrow?
What time are your classes again?
What time are your classes again?
Just from 10 to 12 is all I have tomorrow. So I could do it in the evening. If that's better for most of you, I could do it in the afternoon. So
I have so many other assignments.
I have so many other assignments still that need to be turned in. Early evening would work best for me, but I know that other people, it's
Yeah.
Friday and
Well,
everything.
it looks like
so
most
I'm
people
not
are
sure.
saying that later would be better.
Okay, good.
So
Okay, good.
it looks like people are saying maybe 7 o'clock, and I'm fine with doing it. I'm not
Please.
planning on going on any kind of date. Normally, I maybe not want to do a Friday evening one, but I totally will do it. Okay.
And also, too, if it's all recorded.
If it's
Yeah.
all recorded, then I'm
exactly, because then you
good
can
with
kind of review it
listening to that.
whenever, and I will. It would just be nice to have some people to bounce some ideas off of, because then, if some people are there, then I'll be able to see what are you understanding, where do you need more help, and stuff like that. So, okay. So I know people are saying like 5, and other people are saying 7. Is 7 too late for some of you?
How long is the review going to be?
How long is the review going to be?
Maybe an hour. I'm not even sure if it will go quite that long, but for what we have left to do, I would say about an hour. So probably from 7 to 8 would be good.
Do we not have class next time then?
No. So this is our last day of class because next week is finals week.
Oh, no.
Yeah.
Oh, no.
So this is it. So that's what I'm saying. So next week, all you're doing is taking your finals. We have no other class periods after this one. So that's why I said I would meet with you guys one more time tomorrow to help review some things. Like I said, I'll record it too, so you guys can watch it later if you want. But let's see. Let me just see maybe if you guys will raise your hands. How many would prefer 5 o'clock? Let me see.
I have work that time. That's
what I'm
depressing.
trying to figure out, because some people are 1, 2, 3. 4. Okay, and then how many would prefer 7 o'clock? So take your hands down if you preferred 5 o'clock. Okay, and then now raise your hands if you prefer 7 o'clock. Okay, yeah, it looks like mostly everybody's wanting to, or the majority of people want to do 5 o'clock. So I'll do that. But remember, I will have it recorded, and you can always reach out to me for, some extra help or whatever too, this weekend. If you look through the video and you're like, oh, Becky, can you help explain this part to me again? That would be, good. So, all right, so I'll do 7 p.m. So this is what it's going to be. So 7 p.m. in No, I always do like the personal room. I'll send a message with it and have the link in it. So I'll just I'll have it in my virtual office. Okay, just like a
7 p.m., not 5.
So you're doing 7
yeah.
p.m.
Oh, sorry,
not 5?
5 p.m. That's what everybody wanted. I'm sorry.
Oh.
I just wrote the wrong thing down. Yeah, so 5 p.m. in my virtual office. Okay, but yeah, look for an email from me later today, or an announcement actually gives you more information about the final exam, and also I'll put the link for that in there tomorrow. Okay. All right, guys. Hope you have a great day, and we will hopefully see most of you tomorrow. Okay, and if not, reach out to me individually if you need more help. Okay. Bye.
Does the final exam?
Oh, sorry. Say that again.
When did we decide when the meeting was? When did we
5
decide
p.m.
when the meeting was? Perfect, thank you.
Yep.
Okay, perfect, thank you.
Did somebody else have a question? I thought somebody else was asking me a question too.
Does the final exam have more story problems than fill in the blanks?
I would say it probably has. Let's see. There's 21 questions altogether, and I'd say there's probably like 3, maybe 4 story problems. So yeah, I mean, you do need to know how to do, some of the story problems and stuff. But look over the ones that have been on the past tests and things. Those would be a good indicator of kind of ones that might show up again. Okay.
Thank you.
Yeah,
Okay.
you're welcome.
Thank you.
See you guys. Yeah.
I had a question. So on the part that we're gonna do online, is that like A, B, or C kind of test?
The one that we were doing on Canvas?
Well, you said there's one online.
Well, you said there's one online and then
Well, they're
one
both,
written,
yeah, they're both
right?
going to be on Canvas that you're going to get from, but one's going to be Canvas graded. And so some of the questions Canvas graded will be multiple choice. Some will be, like fill in the blank kind of answers, but you won't have to put any of your work. It's just, okay. But then there's going to be another part where you do need to show your work, and I'll grade your work on it.
Oh, okay. All right.
Okay. Yep.
Okay.
You're welcome.
All right.
See ya.
Thank you.
Bye.
Bye.
Anybody else have questions?
I do have one question for you.
Sure.